Good afternoon, I'm Mr. Ish. Thank you for joining me for this video, quadratic and cubic functions. We're going to be learning the attributes of each of these because as you go into a higher level math, especially pre-calculus, knowing these attributes puts you ahead of the game. For each question here, there'll be two questions. First question will be to do the attributes of the quadratic function. The second question will be the same attributes of the cubic function. Let's look at the quadratic function. It's really called a parabola, but it looks something like this. Let's start itemizing the attributes because these are things you should know. Number one, it is indeed a function because it passes the vertical line test. A vertical line will go through this curve always at only one point. Vertical line test passes. This function as it stands does not have an inverse. You know a function has an inverse, but this function does not have an inverse, which you would demonstrate as this. It doesn't have it because it does not pass the horizontal line test. It doesn't pass it. If you draw a horizontal line, it'll always go through 2 points. It'll never go through a single point. So the horizontal line does not pass in terms of the test, so you cannot do an inverse of this function. What does that mean? It means that each x-axis value should always have only one y value, or each y value should correspond with only one x value. In the instance of a parabola, if you look at any point here and you draw across a line, you can have a situation where one single y value corresponds to two different x-axis values. Hence, you fail the one-to-one test for an inverse, and you cannot have an inverse unless you would limit the domain or erase part of this curve. Then you could very well develop an inverse. But you see, plus and minus x comma y, this could be like a minus 2, this could be a positive 2, but they'll have the same value here, which would be 4, right? 2 comma 4 and minus 2 comma 4. A good example would be just your x squared. That's your quadratic curve right here. It doesn't have the one-to-one requirement to pass the horizontal line test, therefore it does not have an inverse. Another thing, it has a domain minus infinity up to infinity, right to left, minus infinity to infinity, left to right extent. It has a range. If you are looking here at a vertex at the origin, 0 up to infinity including 0. It's a continuous function for sure, because if you were to trace this function, it would very well be traceable without lifting your pen or your marker. It is decreasing function, meaning it's going downwards in terms of the y values, or the y values get smaller as you go from left up to this point, and that's right there, minus infinity up to 0. It decreases, but then the function increases very well from 0 going up to infinity. As you go from 0 in the direction of positive infinity, the function starts increasing. That is, the y values start getting larger and it goes upward. So these are the attributes you need to be familiar with regards to your quadratic function. Let's talk about the cubic function. A good representative of that is x cubed. A graph like that would look something like this. You need to memorize all of these with regards to their graphs. When you see something like this, you should be thinking x cubed. What are the attributes? Well, it for sure is a function because it passes the vertical line test. Any vertical line will always go through only one point. It definitely has an inverse. You can easily do an inverse because it passes the horizontal line test. Think about it. Any line drawn through it horizontally will always go through one point. You'll always have a clear correspondence, a single x always corresponding to a y value. Each y value will always correspond to a single x value, which is why it passes the horizontal line test, which is why then you can have an inverse of that function, meaning you're having clear horizontal lines going through at only one point on your curve. It is definitely continuous. You can trace this entire curve without lifting your marker. There's no break in it. There's no discontinuity in it. There's no decreasing function. It is entirely an increasing function. If you trace it from this point up here, it's always increasing and it's never decreasing. So it's always just an increasing function only, and it's increasing from minus infinity to positive infinity. As you go from left all the way up to the right, your function is always going upwards, and the y values in terms of the output are always getting larger and larger. So it's only an increasing function. There's no decrease in it. It has a good vertex here. As you can see, a vertex of this at the origin, and of course you can translate this and then it won't be at the origin, but the basic x cube always goes to the origin. Lastly, the discussion would not be complete unless we talked about the domain and the range. If you're looking at the domain from left to right, it'll go from minus infinity up to positive infinity. That's easy. And then of course the range for this is from down to up. You're going from the lowest to the highest extent In terms of the cubic function, again, it'll be minus infinity up to positive infinity. And these are all the attributes that you need to be familiar with for the cubic function, a very important function. With that, I thank you for watching. Stay tuned. Have a nice day.